Hello everyone. In this presentation, we are going to study about Ohm's law and the relationship we get from Ohm's law. V is equal to IR or R is equal to V upon I. Hello students. Last time we learned the potential difference and electric current. Now we move on to the next part of the lesson, that is Ohm's law. Before watching the slides, kindly go through the two links. These are for the activity which is given in the textbook for Ohm's law. As you can see in the figure, the activity you would see in the videos. I hope that you all have seen the activity. From the above activity, we can conclude that the ratio of V to I is constant. You must have seen the activity, and in that you would have seen that if you have different voltage or you connect different batteries, first one battery, then second battery, and then third battery, and you measure the voltage and current across the two conductors, you will find that the ratio V is upon I is equal to constant. And if you draw the graph, you can see the graph in the slide. It is also present in your textbook. That is the graph of current on x-axis and potential difference on y-axis. Then you will see that you get a straight line passing through the center. So from this graph we can conclude that V upon I is equal to constant. Now what is this constant? This constant we name as R. R stands for resistance. Now resistance is a property of conductor to restrict the flow of current. Resistance is the restriction to the flow of current. The SI unit of resistance is ohms. It is ohms and it is denoted by the symbol ohm. Unit of resistance, that is ohms. Definition of 1 ohm. If the potential difference across the two ends of a conductor is 1 volt and the current through it is 1 ampere, then the resistance R of the conductor is 1 ohms. This is the definition of ohms. That is 1 ohm equal to 1 volt upon 1 ampere. Obviously, current is inversely proportional to resistance. I is inversely proportional to R. So we write it, when we write inversely proportional, we write it as 1 upon R. Also, I is equal to V upon R. Okay, we just exchange, we shift R on the other side and current on the left hand side. That means if resistance increases, current decreases. If resistance decreases, current increases. So they are said to be inversely proportional. If there is more restriction, then less current will flow. If there is less restriction, more current will flow. A component used to regulate current without changing voltage source is called variable resistance. And a rheostat is often used to change the resistance in a circuit. Electrical resistance of a conductor. And also we will see factors affecting resistance of a conductor. Students, kindly go on the link of the video and try and understand. After you see the video, you will notice that a conductor that offers high resistance is poor conductor and one that offers low resistance is good conductor. Now, the factors on which resistance of conductor depend are: first, the length of the conductor, area of cross section, and third, nature of material. So since resistance depends on the length of the conductor, R is proportional to L. Resistance is inversely proportional to area of cross section. So R is inversely proportional to A. We put these two equations together, the first and the second, and we get R is proportional to L upon A. To remove the proportionality sign, we add a constant which is called as rho. It is used for electric resistivity of a material. It is a symbol used to denote the electrical resistivity of the material. This is the resistivity of the material which will decide whether it is good conductor or bad conductor. The SI unit of electrical resistivity is ohm meter. Now, usually metals and alloys have very low resistance. That is why they are used in electric circuits. Insulators have high resistance, so high resistance that they do not allow current to pass through it. Both resistance and resistivity vary with temperature. If the temperature is high or low, the resistivity may change and even the resistance may change. Here's a table for electric resistivity of some substances at 20 degrees centigrade. Now we will see the substances and their resistivity. See the note down there. You need not memorize these values. You can use these values for solving numerical problems. You can use this table. You need not learn these values. Of course, it is always nice to know the highest resistance and lowest resistance of the materials. We first start with conductors. If you see silver 1.60 into 10 raised to minus 8. So 10 raised to minus 8 means after 0.8 zeros and then 1.6. So that means it is offering very low resistance. Second is copper, aluminium. Just see the resistance of aluminium. This is the reason why we use aluminium or copper wires. Next, alloys. See the resistance of alloys. Even alloys offer low resistance. Insulators. You can see their resistance. We go for the last one, that is paper. 10 raised to 12 means 12 zeros after 10. So you can imagine how high is the resistance. That is why current does not flow through insulators. This table you will find in your textbook as well.